So, hello everybody. Today we will discuss about the first chapter of 12th standard, that is the solid state. So, we know that the matter exists in three different states, that is solids, liquids, and gases. The reason for these three states of the matter are two terms. They are thermal energy and intermolecular force of attraction. The balance between the thermal energy and the intermolecular force of attraction decides the definite shape states of matter. In solids, there is high intermolecular force of attraction and low thermal energy. In liquid, the thermal energy is equal to intermolecular force of attraction. In gases, the thermal energy is greater than that of intermolecular force of attraction. Here, thermal energy always tend to repel the particles from each other, but the intermolecular force of attraction tend the particles of the matter to stay together. So therefore, in the solids, it possesses high intermolecular force of attraction and low thermal energy. In gases, what happens? The thermal energy is greater than the intermolecular force of attraction. Therefore, so it exists in the state gaseous state. This is regarding the introduction to the solid state. So after this, we shall discuss the characteristics of solids. The characteristics of solids are they are highly incompressible and they are rigid. They have definite shape and volume. They have high intermolecular force of attraction. They possess high density. So that is due to the strong intermolecular force of attraction. In this particular chapter, we are going to discuss about very important properties of solids, the crystal lattice, the unit cell, and types of unit cell, then the packing efficiency, close packing, the classification of solids based on magnetic particles, based on the magnetic property and electrical property. These are all the terms that we are going to study in this particular chapter, solid states. Now, let us move on to the classification of solids based on the order of arrangement of constituent particles. Based on the order of arrangement of constituent particles, the solids are classified into two types, that is, crystalline solids and amorphous solids. So, the crystalline solids means the solids in which the constituent particles are arranged in regular order. They are called as crystalline solids. The solids in which the constituent particles are not arranged in the regular pattern, they are called as amorphous solids. These amorphous solids are called as pseudo solids, and the crystalline solids are called as true solids. So why we are calling it as true solids means they have definite shape, they do not show any tendency to flow. That means there is no chance for the distorting forces. If there is small distorting force, then it could be called as pseudo solids. There is no any distorting force of attraction, therefore it is called as true solid. Here the amorphous solids are called as pseudo solids because they have a very small tendency to flow, therefore they are called as pseudo solids. The small tendency to flow is due to distorted or the bending forces or due to the compression forces. It show very small tendency to flow, therefore it is called as a pseudo solid, and therefore it is called as supercooled liquids. All these amorphous solids are called as supercooled solids. Nextly, we shall move on to the differences between the crystalline solids and amorphous solids. The crystalline solids possess definite geometrical shape, that is due to the orderly arrangement of the particles in three-dimensional space. Here, amorphous solids cannot possess any regular geometry, that is, there is no orderly arrangement of particles, therefore it cannot possess a definite geometrical shape. Due to the definite geometrical shape, it possesses very sharp melting point. It doesn't contain any specific melting point. It doesn't contain a sharp melting point. They melts gradually. It melt at a particular temperature. So the crystalline solid, due to its regular geometry or definite geometry, when it is cutted by the sharp-edged tool, it splits into two species, and newly generated surfaces are plain and smooth. So it doesn't contain any regular geometry. Therefore, when they are cut, they splits into pieces, and the newly generated surfaces are irregular in shape. If they are in regular shape, it doesn't present in regular shape. So here the crystalline solid possess a plane of symmetry, or it may be the axis of symmetry. It possesses some crystal symmetry. These amorphous solids do not possess any crystal symmetries. The crystalline solids are anisotropic in their nature. These amorphous solids are isotropic in nature. What is anisotropy? Anisotropy means it is property of the physical property of a substance when gives different value when it is measured in the different direction. There are certain physical properties. When they are measured in the different direction, they gives different value. For example, you can take refractive index. So if you take the refractive index, so if we measure the refractive index in different angle, the refractive index value will be different. So here certain all these properties, example for isotropic properties, you can take mass, density, volume, they are all same. When there you can measure those property in any direction, the property is same. But here in anisotropic properties, you can take refractive index. When it is measured in different direction, it will be different. Thermal expansion, coefficient of thermal expansion, thermal conductivities, they are different when they are measured in the different direction. Therefore the crystalline solids are anisotropic in their nature. So, classification of a solid based on the constituent particle and intermolecular force of attraction. Based on these two things, the solids are classified into many types, namely the ionic solids, covalent solids, molecular solids, and the metallic solids. So let us discuss one by one. First, let us take the ionic solids. So ionic solids, the solids in which the cations and the anions are held together by the Coulombic force of attraction or the electrostatic force of attraction. So they are called as ionic solids. The examples for the ionic solids are sodium chloride, potassium chloride, calcium oxide, and many more are given as the examples for the ionic solids. These ionic solids, they are hard and brittle, having high melting point and a boiling point. They are the conductors for the electricity at either in the molten state or in the aqueous state. Most of the ionic solids conducts electricity in aqueous medium. We can take many inorganic salts like the sodium chloride, potassium chloride. These are all barium sulfate, potassium sulfate. These are all examples for ionic solids. They conduct electricity in the aqueous medium. They do not conduct electricity in the molten state. Very few crystals like calcium oxide, magnesium oxide conducts electricity in their molten state. Nextly, we shall move on to next type of solid, that is covalent solid. The covalent solids means here the constituent particles are atoms and they are held together by covalent bond. In generally, this bonding can be called as electron sharing. Examples for the covalent solids are silicon dioxide, that is quartz, silica, the silicon carbide, diamond, graphite, all are the examples for the covalent solid. The physical nature of these covalent solids are they are hard enough, they conduct electricity, they do not conduct electricity, they are very much insulators for the electricity. The only covalent crystal which conducts electricity is graphite. Except graphite, all covalent solids are insulators for electricity. They have very high melting point and very high boiling point, which is nearly equal to the 4000 Kelvin. Here it is nearly equal to the 5000 Kelvin. Nextly, we will move on to the molecular solids. In molecular solids, the constant particles are molecules which are held by weak van der Waals force of attraction. Weak van der Waals force of attraction means maybe the dispersion force or the polar force, what is that we call a dipole interaction, or it may be the dipole induced dipole interaction. Apart from that, one more bonding force or binding force, or we can call it as the intermolecular force of attraction present here, is hydrogen bonding. Based on the nature of a constituent particle, if it is polar molecule, then we are calling it as polar molecular solid. If it is non-polar in nature, then it is called as non-polar molecular solids. In polar molecular solids, the binding force present is dipole-dipole interaction. In non-polar molecular solids, the binding force is maybe the dispersion force. Here we can take examples of I2, S8, P4, CO2. These are all the example for non-polar molecules. Therefore, the force of attraction between these dispersion force. So, nextly, if you take polar molecules like HCl, then the dipole-dipole interaction will be the intermolecular force of attraction which holds the molecular solids. Nextly, we shall take one more type of molecular solids which are called as hydrogen bonded molecular solids. So here the hydrogen bonded molecular solids, the intermolecular force of attraction will be hydrogen bonding. The examples for the hydrogen bonded molecular solids are starch, sucrose, water, dry ice. These are all the examples for hydrogen bonded molecular solids. So the general physical nature of the molecular solids are they are all soft, they have very low boiling point as well as the melting point. These are insulators for the electricity. Nextly, we shall go for the next type of solid which is called as the metallic solids. So in these metallic solids, the constituent particles are cations which are held together by the metallic bond. The examples for the metallic solids are the sodium, gold, copper. These are all the examples for the metallic solids. These solids are malleable and ductile. They have high boiling point as well as melting point. These are the good conductors for the electricity.